Hello and welcome. This is another series of Hess law. So I'm going to share to you how to answer three questions that you can see already on your screen. So first is actually from the following enthalpy changes, um, you need to calculate the delta H for the reaction. So first and foremost, you need to check the information that you have on your questions, and then what is the information that you already given in the this one. Okay, so if you see this one in this equation, you have C solid right on the left hand side. So you have to check which one of these two equation that has the same side of carbon. So it's actually equation number one. Okay, and then CO2 here, you have a CO2 value or CO2 form is in the second equation. So I need to do is actually I just write C, all right, plus half O2 to give CO, all right. And then I don't change the equation number two as well, right? So I just write CO plus half O2 to give CO2. So when I add these two equations, I can cancel CO, CO. All right, so now I have C, half plus half is actually 1, okay, to give CO2. So now I have a equation that already match with the one that being answered to you. All right, so meaning for delta H for this reaction is actually the additions between the two figures. All right, so it's actually delta H equal to, all right, delta H for this fraction equal to minus 1105 plus minus 283. Okay, so it is actually to, if I'm using my calculator, then I will have minus 393.5 kilojoule, right? So that's the first one. Okay, the step is actually you have to match the information given to you to the questions that given to you. Okay, so that's the first questions. In the second questions, you can see that you have a reaction between xenon, right? Excuse me, xenon with F2, okay, to give uh, XeF2, all right, and then you also have Xe plus F2 to give XeF4. But then your questions, the questions is you have to calculate the value of delta H for XeF2 plus F2 to give XeF4. So how do we do this one? Again, so you have to check, you have to rearrange again the information given to you, all right, uh, based on the equation, based on the questions here. So in the equation, you have XeF2 on the right hand side, okay? But then in the questions, you have XeF2 on the left hand side. So what we need to do, we flip this one. So I will have XeF2 to give Xe plus F2. So if I flip the equation, then the value of delta H also flipped. Okay, so it becomes 123 positive because earlier it was negative. And then I don't change anything in equation number two because I need XeF4 on the right hand side. Okay, so I just rewrite the equation that I have in equation number two to give XeF4 delta H minus 262. All right, so if I add the two value together, so basically I can cancel Xe because I have same substance, but they are in different site, and the number of or the amount of Xe is also one. All right. How about this one? If I cancel F2, meaning I still have one leftover F2 on the left hand side because I have two molecules of F2 on the left hand side, but I have one molecule of F2 on the right hand side. Okay, so so next thing is actually I have XeF2, right? And then I follow this one to give XeF4. Look at this one. The equation that I already manipulate is already matched with the one that the given in the equation or in the questions. All right. So meaning delta H total or for this fraction is actually you just add. Okay, so it is actually 123 minus 262. Okay, if I use my calculator, then I will have minus 139 kilojoule per mole. Okay, now class, you have to remember that the value of this equation is negative, meaning it is actually an exothermic reaction. So meaning if you have a XeF2 reacts with F2 to give XeF4, then it is actually exothermic reactions because the value of delta H is minus 139 kilojoule. Okay, all right. So and then, for example, I have another questions here. Okay, so the table gives some enthalpy change of combustion value, right? So substance, you have a carbon, hydrogen, and then you also have a propanol, all right? So they give you the enthalpy change of combustion. So they have a combustion uh, standard, okay? So for carbon, hydrogen, and propanol. So you are to construct a label and labeled energy cycle to show how this could be used to calculate the enthalpy change of formation. So you need to show, you need to translate this enthalpy change combustions into enthalpy change formations of propanol. So what we can do is actually we just write the enthalpy change formation because it says formation. So based on definitions of delta enthalpy change of formation, it is actually amount of energy or enthalpy change to give a product or compound from its element. All right. So if you see here, you have in propanol you have carbon, the element of carbon. You also have element of hydrogen, and then you also have element of oxygen. Okay, and then it will give you C3H7OH. All right, so this one is S, this one is actually G, this one is actually G, and this one is actually L. All right, now of course we need to balance the equation. All right, so because I have 3 carbons on the right hand side, I put 3 on the left hand side. Because I have 7 plus 1 hydrogen, then I have a 4 times 2, which is 8 of hydrogen. And then because I only have a 1 molecule of 1 atom of oxygen, then I times half of oxygen on the left hand side. All right, so now because you are going to show the use this value, right, to show the enthalpy change formations of propanol, then you can write CO2, all right, and then water at the bottom. All right, so you can actually put the arrow down, okay, for reactions between C plus O2 to give CO2. Okay, C plus O2 to give CO2. And then, of course, this is actually not balanced. So because you have 3 carbons here, and then you only have 1 carbon at the bottom, right? So I put 3. Okay, and then because I have a 4 hydrogen here, but this one actually um, uh, also 4. Okay, now if I put this together, C plus O2, it will give you CO2. If I merge H2 and O2, it will give me H2O. All right, and of course I have enthalpy change of combustion of propanol. Okay, so if I pointing down like this, I mean this way, so this way, so it's actually delta HC of propanol. All right, so you know the combustion always give you carbon dioxide and water when you use excess amount of oxygen. So I just label this one as delta AC. So the value is actually minus 2021. Okay, And then this one is actually because I have 4 water, then I have a 4 times minus 285.8. Remember, yeah, this is actually the enthalpy change of combustion. So I react hydrogen and oxygen to give water. Okay, so this is actually combustion. And then when I react carbon and oxygen to give CO2, this is also combustion because I have 3 moles of carbon dioxide. Therefore, I multiply by 3. Okay, so minus 393.5. All right. So having said that, so I just rewrite the equation. So delta HF. So let me label this one actually delta HF, the one that we're looking for. So to summarize, okay, to summarize the equation, so I can write like this one. Okay, delta HF. Okay, so this way, look at this way, yeah. So this way equal to this way. All right. So meaning delta HF plus negative 2021 equal to this one 3 times minus 393.5 plus 4 times minus 285.8. Now if you do math carefully, then you can get the value of delta H for this one is actually minus 302.7. All right, kilojoule per mole. Okay, so the thing is, the keyword is actually you construct these equations first, right? So you need to know the one that I put in the table, I mean in the box. Okay, so this is actually the enthalpy change formations of propanol from its element under standard condition, and then you need to find the CO2 and water. Why CO2 and water? Because you have a value of enthalpy change combustion. Enthalpy change combustion means that you burn substance in excess of oxygen. So if you have 3 carbons plus oxygen, then you have CO2. It's actually delta H combustions for carbon. And then H2 plus O2 to give 4 water is actually combustions of hydrogen, and the value over here already. Then it's actually combustions of propanol. This way, propanol, combustion of propanol means that you have a propanol and then you have CO2 and water, the value of minus 2021. And then you construct HF plus this value equal to this value and this value. All right. Then you can get this value. Then you already finished the questions successfully. Okay, so I hope that helps you. Thank you again for watching.